This whole unit has been dedicated to proving two triangles what? Congruent, yep. And we're going to stick to that today. Showing two triangles are congruent, but a little different way. Probably a couple ways you guys had exposure to in the middle school. If I take a triangle and flip it, reflect it, is it still congruent to the original one? Did I change the size or shape at all? No, so they're still congruent. What about if I slide a figure? Do I change the size or shape? No, so they're still congruent. And when I say slide, the fancy word you probably used was translation. And the third thing I could do is, what if I turned a triangle? Still congruent to the original? All right, let's not use the word turn, though. Let's use rotation. Anybody see a missing term that maybe you used in the middle school that's not up here for a reason? Eric? Dilation. Why isn't dilation up here? Because it's going to change the size. Yes, make it smaller or bigger. I want to group these three terms, reflection, translation, and rotation, under one vocabulary term now. All three we're going to refer to as a rigid motion. Okay, rigid motion. That is anything, does not have to be these three, but anything that I can do to a triangle that at the end, the image and the pre-image are congruent to each other. I could slide it, flip it, turn it, whatever is the case, as long as the first one is congruent to my ending triangle. All right, we refer to that as a rigid motion. All right, a rigid motion. Anything that keeps the size and shape the same. All right, today's going to go very quick, and you're going to have plenty of time to start the assignment. So I just want to make sure we're okay with those three. So to go from one triangle to the other in 1A, what did I do there? What rigid motion did I perform? Okay, on 1A, what rigid motion did I perform there? Because they are congruent. 16, what rigid motion did I perform? That's a reflection. Way to get us started on the right foot. 1B, what rigid motion is being performed to go from one figure to the other? Oh, 23. That is a rotation, yes. And, 1C, what am I doing there to make sure those guys match up? 8? Yeah, I'm sliding that figure over. Translation. Any issue? All right, so all I want to do now is on the graph. How can you prove to me that a rigid motion did happen, that one is congruent to the other? Go right ahead. I'll give you guys a minute or two here to graph triangle XYZ and ABC. All right, well, it looks like to go from triangle ABC to XYZ, it looks like I'm performing a what? Which one out of those three transformations does it look like I'm performing? 22? It looks like a reflection, yeah. But now we have to actually prove that it is. All right. If it's a reflection, which we know is a rigid motion, these two triangles should be what at the end here? Congruent. If this is really a reflection, these two triangles should not have changed its size. They should be congruent to each other. I believe it was, I erased it already, so I'll go back to you guys. 3 methods of proving triangles congruent, if that's what I'm going to have to do here. 3, one method. Side, angle, side. Let's keep this going here. What are my 5 methods? Come on. Here we go. 6. Angle, angle, side. And first there, Mike, I thought you were only just getting me one letter. 18. Side, side, side. Bang that one out there. Yep. Next up, 16. Angle, side, angle. And of course, always the 5th and forgotten one. Don't forget about it next week. 20, nothing. How about, yep, we're on fire. 20, yep. 4 times. 4, there we go. HL, yep. That was a lot of work just for me to ask this question. What's the only way on a graph we're going to prove these two congruent? Side, 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 yes. And I am not going to force you to do 6 distance formulas yet. I'm going to assign a side to every group right now. So triangle ABC, triangle XYZ. You and your group are responsible for the following. Side AB, this group right here in the corner. BC, this group right in front of me here. AC, group in the back corner near my desk. Middle group here, let's go XY. This group in the corner over there, let's go XZ. And this group along with Dylan, let's go ZY. And you guys know the deal. Simplest radical form if possible. Down, everybody. Group AB, what do you got for me? Square root of 17. Yep. How about the BC group? Square root of 29. AC group had a little simplest radical form there. Square root of 40, which breaks down to 2 radical 10. Nice job. So I'm hoping the other 3 groups, we had some matches up here, if this is indeed a reflection. XY group, what do you got for me? There we go. There's 1 pair congruent to each other. How about the XZ group? There's another matching pair. And let's really confirm this is a reflection. ZY, square root of 29. Yes. Okay, last thing I need some conclusion statement that shows, yeah, this is a reflection. All right? Reflection. It is a rigid motion. Because what did I know about the triangles? The 2 triangles are triangle ABC. Better watch yourself here because I don't think it goes in alphabetical order, the next one. I don't think it goes XYZ here. Just throwing that out to you. If I go ABC, what do we got to match it up with? Because it's not XYZ. XZY, yep. Be careful there. That's a little trap. By, how do you know they're congruent? Side, side, side. Okay. Okay, that's nice. You only had 1 side to do. Can you handle the rigors of a full one now? That's what the next one is. You're going to graph it, do it all out. I'm going to put my work up here. The only time you look up is when you think you're done. Don't look up just the copy. All right, and then once my work matches yours, grab a textbook, grab your Chromebook, and you can start the assignment. Halfway into class already. Make sure your work's neat. Well, first of all, I guess we should talk here before you start. What do we think's going on here? looks like a. It's both. You could say it's a rotation. And also correct, because take a look. If you took KLJ and reflected it through 0, 0, the origin, it'll match up PQR. So rotation, reflection, you're right either way. Yep, a double reflection, you'll find out later on in the year, does equal a rotation. That's not what we're doing. That's not what we're doing. Everyone's doing 6 distances here.